Alright, we're going to look at something called estimation. Sometimes all we need is an estimate of the answer. We don't actually need the exact answer, just something close to it. And often estimation is like just easier, it's quicker to do, and it will give us like a near enough answer. We're going to look at some different examples from your textbook, worked example 21 to worked example 25 in this video. So for worked example 21, Marilyn and Kim disagree about the answer to the following calculation, which you can see the calculations listed here. Marilyn thinks the answer is 56.6, but Kim thinks it's 46.6. So one of them's right, one of them's not right. We can do a quick estimate to determine who is correct. If we look at each of the values here, so for 7, I'm looking here, for 7.3, that's close to 7. The next one, 7.1, is close to 7. 6.9 is close to 7. 6.8 is close to 7. 7.2 is close to 7. So 7.3, so 7.4, and so 6.6. So I could say that all of those there are close to 7. So if I add 7, 7, 7, 7, 7, 7, 7, 7, that's 8 lots of 7. The answer is approximately 56. So you would have to say that by doing that, who is more correct, Marilyn who says it's 56.6 or Kim who says it's 46.6. Marilyn is correct because her answer, on a quick calculation, her answer is closer. So we approximated 56, she said 56.6, Kim said 46.6. So a little quick estimation would be that Marilyn is correct. Okay, let's look at the next worked example 22. Consider the number 39,461. It wants us to round to the nearest thousandths. So to the nearest thousandths is asking us, is this number closer to 39,000 or is it closer to 40,000? This number is 39,461. That is closer to 39,000 because the halfway mark would be 39,500. It is under that. So rounding this number to the nearest thousand would be 39,000. Okay, rounding this same number here to the nearest hundred. It is saying, is this number closer to 39,400 or is it closer to 39,500? So remember, the number is 39,461. 461, that is closer to 500 than it is 400. So the number rounded to the nearest 100 is 39,500. Okay, and that number rounded to the nearest 10. Well, the 10 column is the 6, where the 6 is. So it's saying, is the number closer to 39,460 or is it closer to 470? Okay, so which is it closer to, because the 6 is the 10 column? Well, 39,461, it is closer, 61 is closer to 60. So rounded to the nearest 10, it's 39,460. Okay, let's look at worked example 23. It wants an estimate of the following calculations by first rounding each number to its first digit. So if we look here, 394, rounded to the first digit is this digit here. So is that number closer to 300 or 400? Well, it's closer to 400. So we say 394 is approximately 400. We are adding 76 rounded to the first digit. 76 is closer to 80 than it is 70. So we round that to 80. And then we subtract, rounding to the first digit, 121. Is that closer to 100 or is it closer to 200? Well, it's closer to 100. So an approximate would be 400 plus 80 minus 100, which is approximately, and that's our approximate sign, equal to 380. And if we actually did that sum on the calculator, so we did 394 plus 76 minus 121, we would get 349. So our approximate is not too bad. Alright, let's look at the next one. 692. Rounded to the first digit. 692 is closer to 700 than it is to 600. So we say 700. We times it by 30, because 32 is closer to 30 than it is to 40. We divide it by 20, because 19 is closer to 20 than it is to 10. And we round 87 to 90, because 87 is closer to 90 than it is to 80. Now doing some cancelling, we can cancel that 0 with that 0, that 0 with that 0. We can also say 3's into that goes once, 3's into 9 goes 3. So we have 70 over 6. Sorry, we can also say that 2 goes into both of them. So we have 35 over 3, which is approximately 12. Because 36 divided by 3 would be 12, but remember we're estimating. So the answer to this is approximately 12. If we put this sum into the calculator, let's put it into the calculator and we round it to 1 decimal point. The actual answer rounded to 1 decimal point is 13.4. So the answer is 13.4. The estimate, not too bad, the estimate is 12. Okay, worked example 24 wants an estimate for 537 divided by 40. In A, it wants us to round the dividend, the top number, to the nearest 100. It wants us to round it up to the nearest 100. So 537 rounded up is 600. So it's 600 divided by 40. We can say that 40 goes into itself once and 40 actually goes into 615 times. So the answer is approximately 15. Next one, it wants us to round the dividend to the nearest 10. So 537, the nearest 10, is it 530 or is it 540? Well, we round it to 540 because it's closer. So 540 divided by 40. We can say that 20 goes into that twice. 20 goes into this 27 times. 27 divided by 2, so that answer is approximately 13.5. Okay, C is a little bit harder. It wants us to round the dividend to a multiple of the divisor. Well, the divisor is 40. It wants us to round this to a multiple of 40. Well, the closest multiple of 40, 520 is a multiple of 40. The next multiple of 40 is 560. So 537 is actually closer to 520. So we round the dividend to the closest multiple of 40, which is 520. And 40 goes into that once, 40 goes into that 13. So the answer to that is approximately 13. Okay, in the last example, it wants us to work out the approximate answer for 132 times 77 divided by 55. I'm going to round each of those numbers to the first digit. So 132 rounded to the first digit, that's closer to 100 than it is 200. 77 rounded to the first digit, 77 is closer to 80 than it is 70. And I'm going to divide it by, well, 55. Is it closer to 50 or 60? It's halfway, so we normally round up. So we say it's closer to 60. Doing some cancelling, cancel, cancel. I've got 2 goes into that 3 times, 2 goes into that 4 times. So it's approximately 400 over 3, which is approximately 133. What the question is saying is that the exact answer has these digits and there is a decimal point in there somewhere. So let's work out where we put the decimal point so that it is close to 133. That's our estimate. We wouldn't put the decimal point there because 1.848 is not close to 133. We wouldn't put the decimal point there because again 18.48 is not close to 133. But if we put the decimal point there, our exact answer, it's 184.8 because that is close to our estimated answer.